Hello, welcome back. Today we're going to talk about two methods for sharing continuous items. Continuous, remember, means that these items can be cut up. For example, food and land. The first method we're going to talk about is called the divider-chooser method. This is a method for two people sharing a continuous item. So it's important that it's two people, and it's important that the item is continuous, meaning that we can cut this up. So what's the idea behind this divider-chooser method? Say I'm sharing this pizza with my sister. Okay, so two people. How do we cut this up so that both of us are happy? So first, let me show you a way that's not going to work. What if I say, let's cut it this way. I'll take this piece. I'll give my sister the crust. I'll be happy, but my sister will probably be not happy. Okay, so that's not going to work. It's not as simple as just cutting it down the middle. Because if we cut it down the middle, I'm probably going to take this piece and I'll give my sister that piece. I'm happy, but she might not be happy, right? She might say, hey, your piece has more pepperoni. I want that piece. So the way the divider-chooser method works is one person's going to cut, but the other person will choose. So sometimes this method is called the I cut, you choose method. So say I'm the person who cuts. Because I can't choose which piece I get, it forces me to cut it in a way that I'm happy with either piece. So it forces me to cut it as evenly as possible in my eyes. So for example, I might cut it maybe like this. So there's about the same amount of pepperoni on this slice as on this slice. So if I care about the pepperoni, I might cut it like that. And then my sister will choose, and then I'm going to be happy with either piece. So she gets to choose, she's happy. I cut it in a way that I'm happy with both pieces, so I'm happy. All right, let's talk about some strategy. Situation we have here, we have Bart and Lisa who are sharing a cake that's part vanilla, part chocolate. Okay, it looks like this. Bart only eats chocolate, which means he doesn't want the vanilla part at all. If he gets any vanilla, he's going to cut it off and throw it away. Bart is the divider. How should he cut this cake? Should he cut it like this? Down the middle like that. Remember, whoever cuts, the other person gets to choose. So he probably doesn't want to cut it like this because Lisa gets to choose. What if Lisa picks the piece on the right? That would leave him with the piece on the left, which is all vanilla, no chocolate, right? He's not happy. So he probably doesn't want to cut it like this. Should he cut it like this? Probably not either, right? Because it looks like the piece on the bottom might have more chocolate. So what if Lisa picks that piece on the bottom that has more chocolate? He gets less chocolate, he's unhappy. So the idea here is that whichever piece you want, you should try to cut that part up as evenly as possible. So the divider should cut up the piece that they want as evenly as possible. So for example, one way that Bart can do this to ensure that there's the same amount of chocolate in both pieces is to cut it down the middle like this. Okay, for sure, there's the same amount of chocolate in either piece. If Lisa picks this piece, he's left with this piece, which has half of the chocolate and a bunch of vanilla, which he doesn't care about anyway. So he's guaranteed at least half of the chocolate. If Lisa picks the piece on the left, he gets the piece on the right, which is still half of the chocolate and some vanilla, which he just cut off. So let's try example 2. Example 2, Bart and Lisa again are sharing a cake that's part vanilla, part chocolate. This time Lisa only eats vanilla. Lisa is the divider. How should she cut this cake up? So look at the piece that she wants, which is the vanilla, and you can ignore the other piece. So looking at just the vanilla, she wants to cut this vanilla up as evenly as possible. So she's probably going to cut it down the middle of the vanilla. Okay, that way, no matter which piece Bart picks, she's guaranteed half of the vanilla for sure. Now let's connect this divider chooser method with what we talked about in the last lecture. So this is the same example we talked about in the last lecture. Bart and Lisa here are given a pizza that costs $27 and is cut into 10 pieces. Part A, what is a fair share for each person? So remember, consider this as cash. So they got $27 in cash. How much money does each person deserve? So we'll take the 27 and divide it by how many people we're sharing this among. So we're sharing this between Bart and Lisa, so 2 people. 27 divided by 2. 13.5. Or $13.50. Each person deserves $13.50 worth of pizza. Now, this pizza is 3 slices are veggie, 3 are cheese, and 4 are pepperoni. So let me label the pizza. We have 3 veggie, so V, 3 cheese, and 4 pepperoni. Let me label the other pizza also. So 3 veggie, 3 cheese, and 4 pepperoni. Now, each person views the pizza differently, right, depending on their preferences. So what I want to do here is, for Bart, I want to put values around for each slice so that it adds up to 27, the value of the whole pizza, and it also reflects his preferences. So Bart does not eat pepperoni at all, right? So the pepperonis are worthless to him. So for him, the pepperonis are worth 0. He likes cheese 4 times as much as veggie. Okay, so for the cheese, I'm going to label with 4 times X. And then the veggie will be regular X. Okay, so what this means is whatever number I put for the value of the veggie, the cheese will be 4 times that. And now we add up the X's around the pizza. So this is 1x, 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 4x, 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 and then zeros. So 1 plus 1 plus 1 plus 4 plus 4 plus 4 plus 0 plus 0 plus 0 plus 0. How much is that total? The 4's, 4 plus 4 plus 4 is 12, plus 1 is 13, plus 1 is 14, plus 1 is 15. So 15x. Set it equal to the total value of the pizza. So total value of the pizza, be careful, it's not 13.5. The total value of the entire pizza is 27. Now get the x by itself. So get rid of the 15. To get rid of the 15, you're going to divide both sides by 15. All right. Left side, the 15s cancel out. You get x. Right side, 27 divided by 15. 1.8. Now let me write down the value of each slice for Bart. Let me write it over here. We had veggie, we had cheese, and we had pepperoni. 1.8 is X. So which slices did we label as X? The veggies. Okay, so the veggies are X, which is 1.8. The cheese, which we labeled as 4x, is going to be 4 times the 1.8. So 4 times 1.8 is 7.2. And then the pepperoni, we labeled as 0 because it's worthless to Bart. Pepperoni is 0. Okay, these are Bart's values. And then we'll do the same thing for Lisa. Okay, Lisa likes pepperoni twice as much as cheese. So twice meaning 2 times. So I'm going to label the pepperoni 2 times. She likes veggie 3 times as much as cheese. So veggie will be 3 times. So 3x on the veggie. Cheese, it doesn't say that she does not like cheese. So the cheese will be regular x and not 0. Add up the x's around the pizza. So this is 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3, and then plus 1 plus 1 plus 1. So if there's no number, it's 1x. The 2's, 2 plus 2 plus 2 plus 2 is 8. The 3's are 9. So 8 plus 9 is 17. 18, 19, 20. So 20x. Set it equal to the value of the entire pizza, which was the 27. And then get the x by itself. I need to get rid of the 20, so divide both sides by 20. Left side, the 20s cancel out, and you have x. Right side, divide, 27 divided by 20. 1.35. And now let's write down the value of each type of slice for Lisa. So we have veggie, cheese, and pepperoni. The 1.35 is x. So which slice did we label as regular x? Regular x was the cheese. So the cheese are 1.35. The veggie we labeled as 3x. So that means 3 times the 1.35. So 3 times 1.35. 4.05. Pepperoni is 2 times x, so 2 times the 1.35. $2.7. All right, so these are the values of the slices to Lisa. So that's a review of what we talked about last time. So now the new stuff, a divider chooser example. Okay, so now we're going to determine which slices to give to each person. So Lisa here is going to be the divider, and she's going to divide the pizza into the 2 piles below. So pile 1 has 1 pepperoni, 2 veggie, and 2 cheese. Pile 2 has 3 pepperoni, 1 veggie, and 1 cheese. So as the divider, she's going to want to cut this pizza up as evenly as possible in her eyes. So let's check that she actually did this. So let's check the value of pile 1 and pile 2 for Lisa. So pile 1 has 1 pepperoni, so 1 times the value of pepperoni for Lisa. Lisa valued pepperoni 2.7. Plus 2 veggie, so 2 times the value of the veggie, so 2 times 4.05. Plus 2 cheese, so 2 times the value of the cheese for Lisa, which is 1.35. And let's check this. 1 times 2.7 plus 2 times 4.05 plus 2 times 1.35. 13.5. Let's check pile 2. Pile 2 has 3 pepperoni. So for Lisa, that's 3 times the value of pepperoni, which was 2.7. Plus 1 veggie. 1 times the value of the veggie, 4.05. Plus 1 cheese. So 1 times the value of the cheese for Lisa. So cheese for Lisa was 1.35. So 3 times 2.7 plus 1 times 4.05 plus 1 times 1.35. 13.5. Okay, so she did the right thing. She divided the pizza up into 2 piles, and both piles are worth the same. So she's okay with either pile. Okay, so she did the right thing as the divider. Now Bart gets to choose. So which pile would Bart choose? So we're going to look at the value of each pile to Bart using Bart's numbers, and then he's going to choose whichever one is more valuable to him. Okay, so for pile 1, so now we're going to use Bart's values. So pile 1 is 1 pepperoni, so 1 times the value of pepperoni for Bart, which is 0, so 1 times 0, plus 2 veggie, 2 times the value of veggie for Bart, which is 1.8, plus 2 cheese, 2 times the value of cheese for Bart, which was 7.2. Right, so the value of pile 1 for Bart is 1 times 0, plus 2 times 1.8, plus 2 times 7.2. 18. Pile 2, 3 pepperoni, so 3 times the value of pepperoni for Bart, which is 0, plus 1 veggie, so 1 times the value of a veggie for Bart, which was 1.8, plus 2 times the value of, 1 time, there's 1 cheese, 1 time the value of a cheese for Bart, which is 7.2. So 3 times 0, plus 1 times 1.8, plus 1 times 7.2. 9. Okay, so pile 1 in Bart's eyes is worth $18 worth of pizza. Pile 2 in Bart's eyes is worth $9 worth of pizza. So which pile would he pick? So obviously he's going to pick the one that's worth more. So he's going to pick pile 1. So Bart will choose pile 1. Which means Lisa is going to get the other pile, pile 2. And both people are happy. So Bart gets pile 1, which is $18 worth of pizza. In his eyes, he deserves $13.5 worth of pizza. So he got more than he deserves. He's happy. Lisa gets the other pile, which is pile 2. Pile 2 in her eyes is worth $13.5. In her eyes, she deserves $13.5 worth of pizza, and she got $13.5 worth of pizza. So she's happy. I said earlier that the divider-chooser method is a method for 2 people sharing a continuous item. So it's important that it's 2 people. Because once you have more people, once you have 3 or more people, you run into issues with this divider-chooser method. So let me show you an example where this doesn't work. So here we have a vanilla and chocolate cake, and we have 3 people. So Adam likes only chocolate, Brandon likes only vanilla, and Charlie likes only vanilla. So let's say that Adam is the divider. Which means Brandon and Charlie would be the choosers in this case. So just like before, Adam is going to want to cut up the piece that he wants as evenly as possible. He wants the chocolate. He's going to try to cut up the chocolate as evenly as possible. So let's say he cuts it up like this. Right. He's tried really hard to cut up the chocolate into 3 equal pieces, right? So that no matter which piece he gets, he's guaranteed at least a third of the chocolate. So we have 3 pieces here. We have the piece on the left, which has the vanilla part. We have the piece in the middle here, which is just chocolate. And then we have the piece on the right side, piece 3, which is just chocolate. Now, what happens next? What happens next is the other 2 people get to choose. So it depends on who gets to choose next. Say Brandon chooses next. Which piece is he going to choose? He sees 3 pieces, piece 1, piece 2, and piece 3. He likes vanilla. He's probably going to choose piece 1. Okay, so Brandon gets piece 1. Now, Charlie gets to choose. So Charlie likes vanilla, but piece 1 is gone. Piece 1 went to Brandon, so he's only looking now at piece 2 and piece 3. He's unhappy, right? Piece 2, piece 3 have no vanilla at all. So Charlie is unhappy. So this is a situation where divider chooser leaves one person unhappy. So divider chooser is not going to work for 3 or more people. For 3 or more people, we use another method called the lone divider method. So the lone divider method is a method for 3 or more people sharing a continuous item. So once again, these are things that you can cut up. So lone divider means that there's still the person who divides, but then there's no choosers. We're not going to have choosers. So one person divides, and then we're going to take a step back and figure out what to do next. So instead of going through the words here, let me show you the steps with an example. Example 4. Situation we have here is we have 4 people, Bart, Milhouse, Lisa, Maggie, who are sharing this piece of land. The way the lone divider works is one person is going to divide. So one person is going to cut up this land into 4 pieces. Once we have the 4 pieces, each person is going to look at each piece and decide on how much each piece is worth to them. And that's what this table shows. Bart looks at piece 1. Piece 1 is worth $60,000 to him. Piece 2 is worth $90,000 to Bart. So everyone's going to have a slightly different value on each of the pieces because everyone's going to look at each piece differently, and it's going to be valued differently because each person has slightly different preferences. The first question is, let's decide on who actually did the cutting. So who was the divider? And remember, the strategy for the divider is to try to cut up the land into pieces that are as even as possible in their eyes, because they can't choose which piece they get at the end. So they want to cut it up so that they're happy with all the pieces. So all the pieces should be worth the same to the divider. So who was the divider? Look at the values and look at who has the same value on every single piece. Look at Milhouse. Milhouse valued piece 1, 75,000, piece 2, piece 3, piece 4, 75,000. So Milhouse was the divider. And I'm going to write his value on each piece because that's important. Because that's actually the fair share number. And that's important because that number is what each person deserves. So each person deserves $75,000 worth of land for them to be happy. Now, the next step is what's called the declarations. So for each person, we're going to go through the list for each person and decide on which piece or pieces they would accept as a fair share. So for Bart, we're going to look at each piece. He would accept any piece that is $75,000 or more, right? So he deserves $75,000 worth of land. He will accept any piece that is $75,000 or more. So piece 1 is $60,000. He won't accept that. Piece 2 is $90,000 to him. He would take piece 2. So piece 2 is one of the pieces that he would accept. Piece 3 is $60,000. Nope. Piece 4 is $90,000. Yes, he would accept because it's $75,000 or more. So he would accept pieces 2 and 4. Milhouse, who was the divider, right? All of his pieces are $75,000 or more. So he would accept any of those pieces. And this is true, always true for the divider, because the dividers should be able to, well, they cut it up in a way that they're happy with any of the pieces. So the divider would accept any of the pieces. Lisa, $30,000, $45,000, $105,000, $120,000. So any pieces that are $75,000 or more, Lisa would accept. So Lisa would accept 3 and 4. Maggie, $90,000, $97,500, $52,500, $60,000. She would accept any piece that is $75,000 or more. Piece 1 and piece 2. Okay, so we have now a list of all the pieces that each person would accept. Now we try to give each person a piece that they would accept so that everyone's happy. And at this step, don't look at the table anymore. Okay, so forget about the table. Just look at the declarations that you made in part B. Okay, and try to give everybody a piece that they would accept. So a hint here is, well, a strategy here is deal with Milhouse, the divider, last. So Milhouse would accept anything. Because he's so flexible, it's easiest to deal with him at the end because we can just give him whatever's left. Okay, for everybody else, try to look for the person who is most picky. So here it's about even because everybody had two options that they would accept. Okay, so you can start anywhere. Let's start with Bart. So Bart would accept piece 2 or piece 4. So give him one of those. Doesn't matter which one you give him. Pick one. Let's give him 2. Okay, Milhouse, I said we'll take care of last. Next up is Lisa. Lisa would accept 3 or 4. Which one should we give Lisa? Doesn't matter. Pick one. Let's pick 3. Maggie. Maggie would accept piece 1, piece 2. Which one should we give Maggie? We can't give her 2 because we already gave 2 to Bart, which means we can only give her 1. So we have to give her 1. And then Milhouse is going to get whatever's left. So what's left? 4. 4's left. Okay, and that's an answer. There's multiple answers here that would work. So we would just want to give everybody a piece on their list. That's it. And we're not looking at the numbers here, right? I just want to give everybody a piece that they would accept. So Bart got piece 2, which was worth $90,000 to him, right? He's happy because it's more than what he deserves. Milhouse got piece 4, which was $75,000. He's happy because it's $75,000 or more. He got what he thinks he deserves. Lisa, we gave her 3, which is $105,000, which is more than what she deserves. And then Maggie got 1, which is $90,000 in her eyes. So she got more than what she thinks she deserves also. So everybody's happy. So it's important to note here that there's multiple answers here. This might not be the best answer, right? Because some people prefer some pieces more than other, right? So Maggie prefers piece 2 more than piece 1, but we gave her piece 1, and that's okay. So we're not trying to make everybody as happy as possible, right? I just want to make everybody happy in the sense that they get at least what they deserve, okay? That's what the method we're talking about here, right? Methods where we're trying to make everybody as happy as possible are more advanced, and we're not going to talk about in this class. Let's try another example. So sometimes with the lone divider method, you end up in a situation where you get stuck. So this is an example of one of those. So let me show you what it looks like when you get stuck. Same situation, we have 4 people sharing land. They divide into 4 pieces. First question, who was the divider? So look for the person who valued each piece exactly the same. So who is the divider? Looks like Lori. So Lori valued each piece $50,000. She's the divider. And let me also make note of her value on each piece because that number is important. Because that's the fair share number. Each person deserves $50,000 or more worth of land. Okay. Now, declarations for each person. And what this means is we're going to go through and list out which pieces each person would accept. So each piece or each person would accept any piece that is $50,000 or more in their eyes. For Matt, $40,000, $30,000, $40,000, $90,000. Matt would only accept the $90,000, right? That's the only one that is worth $50,000 or more. So Matt is only 4. Brenda, 40,000, 60,000, 40,000, 60,000. The only ones that are $50,000 or more would be piece 2 and piece 4. So she's going to accept 2 or 4. Lori, who was the divider, right? If she did it right, she should accept any of those pieces, right? All of those pieces are $50,000 or more, so she would accept any of those pieces. Brandon, 40,000, 65,000, 35,000, 60,000. So he would accept piece 2 and piece 4. So those are the only 2 pieces that are 50,000 or more. So he is 2 or 4. Okay, now forget about the table and just look at the list of pieces that each person would accept and try to give everyone one of the pieces that's on their list. Okay, so strategy here, deal with the divider last because she's the most flexible. She'll take anything. So you can just give her whatever's left. And start with the person who is most picky. So Matt is actually the most picky. He only wants one piece, right? He's not flexible at all. So I'm going to start with Matt. And we have to give him 4 because that's the only piece that would make him happy. So give Matt 4. Okay, next we have a tie between Brenda and Brandon. They both are flexible in the sense that they have 2 options. So Brenda likes 2 and 4, but we already gave 4 to Matt, so we have to give Brenda 2. Lori, we said we'll take care of last, and now Brandon. So Brandon likes 2 and 4. Which one can we give him? None, right? 2, we already gave to Brenda. 4, we already gave to Matt. So now we're stuck. So we can't give Brandon anything that he likes. So we're stuck here. So what happens when you're stuck? So when you're stuck, we do 2 things. So when you're stuck, we're going to give the divider one of the pieces that nobody's fighting over. Okay, so in this case, Lori is the divider. And let's give her a piece that nobody is fighting over. So Brandon wants 2, 4. Brenda wants 2, 4. Matt wants 4. So the pieces that nobody wants is 1 and 3. So pick one. Give her one of those. So let's give her 1. Okay, it doesn't matter. You can also say 3 here. And then what you do is you're going to repeat the process. So we're going to repeat the process. Okay, Lori, we gave her a piece that she wants, so she's done. So we're going to repeat the process with whoever's left, which is Matt, Brenda, Brandon. And with the pieces that are left. Pieces that are left are 2, 3, and 4. Okay, and that's it. And that's what I want as an answer. So we can't really continue because what I mean by repeat the process is they're going to take pieces 2, 3, 4, combine them again, and now restart the process. So one of these people are going to cut up, and then they're going to value each piece again, and then they're going to try to do the same thing again to make everybody happy. Now, we can't really go on and find an answer because whoever cuts this up, they may cut it up in different pieces, and the people will value each piece differently. So we'll need another table, which we don't have, right? Because we don't know how the person is going to cut it up yet. So this is kind of as much as we can say right now. So we're going to give the divider a piece that no one fights over, and then you're just going to state that we're going to repeat the process and then state whoever's left with the pieces that are left. So 2, 3, and 4 here. One last example. So same situation, we have 4 people sharing land. First question is, who is the divider? So look for the person who valued each piece exactly the same. Zoe. So Zoe valued each piece 2,500. So Zoe is the divider. And I'm going to make note of her value on each piece, because that's important. That's the fair share number for everybody. So everybody deserves $2,500 worth of land or more. Now for each person, we're going to list out each piece that they would accept. So the pieces that they would accept would be any piece that is 2,500 or more. So for Maggie, piece 2 works, piece 3 works, and that's it. So 2 and 3. For Meredith, piece 1's good, piece 2 is good, 3 and 4 are no good. So this is just 1 and 2. Holly, 1 is no good, 2 is no good, 3 is good, and 4 is no good. So once again, these are the pieces that are 2,500 or more. And then Zoe, who was the divider, she would accept any of those pieces, right? So all those pieces are 2,500 or more. So Zoe would be any. Okay, now for part C. So for part C, we're going to try to give everybody one of the pieces that are on their list. So forget about the table. Just look at the list that you made in part B and try to give everybody one of the pieces that's on their list. So as a strategy, Zoe, the divider, deal with that person last because they're the most flexible. They will take any piece. So you can just give them whatever's left at the end. Start with the person who is most picky. So the person who has the least amount of options on their list. So start with Holly. Holly only wants 3. So for this to work, for everybody to be happy, for Holly to be happy, we have to give her 3. So we have to give her 3. Maggie and Meredith, it doesn't matter who you go with next. Maggie, let's go with Maggie. Maggie likes 2 or 3, but we already gave 3 to Holly, which means we have to give Maggie 2. Next up is Meredith. Meredith likes 1 or 2. 2 we already gave to Maggie, so we have to give Meredith 1. And then Zoe likes anything, so give her whatever's left. So what's left? 4. So this one works. So we didn't get stuck here. This one works. We gave Maggie 2, which is on her list. We gave Meredith 1, which is on her list. We gave Holly 3, which is on her list, and we gave Zoe 4. She doesn't care about any of the pieces. She will take any of them. So everybody's happy. All right, that's the lone divider method. Have a great day, and I'll see you in the next one.